Morning, Year 12s. We're here stood on Millook Haven Beach, which is in North Cornwall, just south, of Widmouth Bay. Part of your A-level geography course is to do a NEA, non-examined assessment, which is a piece of coursework basically. We're going to demo today how to do the coastal geography one, an example of one, okay, with some techniques and so on that you can look at, and then I've got a booklet as well which I'll send to you, which will help you to get an idea behind it as well. Mr. Till is helping me.
Good morning, and what he just said.
The first thing I want to do really is give you a bit of theory behind it quickly, okay, and then we're going to talk about the equipment. So if you come here, Jacka, and you can see the board. Okay, so this is a booklet, okay, so a study of the physical processes that influence the morphology of the beach at Millook Haven. That's one. It could be also, that's one take on it. You could also a comparative analysis of the morphologies, maybe the beach morphologies of Millook Haven and Widmouth Bay or Northcote Mouth. That's another one as well. How do physical processes influence beach morphology at Millook Haven? Okay, so there's 1, 2, 3 different sort of ideas of this sort of study. Okay, so that's that.
We usually get those signed off with the coursework moderator, don't we, Mr. White?
Yeah, you have to come up with a title and a methodology, and how you're going to collect the data, what hypotheses you're trying to test as well, which we'll try and talk to today. It's quite straightforward. It's like very much an inquiry in steps, and I want to just show you sort of the basics today really, and then we get our teeth into it more as time goes on, don't we, Mr. Tyrrell? Alright, so if you look back on here then, the theory behind it really is you've got your water's edge, okay, and then you've got that's that sort of low water mark, and here you have your cliff, okay, and the sediment is sort of, that's like the profile. So you're going to do a long profile. You're going to measure the angle of the slope from the low water mark up to the back of the beach, the back shore it's called, and that's the foreshore, okay, and you do the angle of the beach, and that's over time. So you come back over different months to see how it's changed, because it will change. And somewhere like Millook Haven, you'll see in a minute, it really is quite dramatic changes. So that's one. We measure that using, what do we use that, Mr. Tyrrell?
So we have, for our profile drawing, we have our 2 ranging poles. Okay, we'll show you how to use those a bit later on, but you need a pair of ranging poles. And you need a clinometer to record the angle between the 2 ranging poles. And lastly, you'll need a tape measure so that you're able to measure the distance between the two, between the bottom of the slope and the top of the slope.
Okay, so we'll look at the angle of the slope. We're also going to look at sediment, and we use what's called sediment size and shape, and we use what's called the Power's roundness scale. Mr. Power, roundness scale, and we measure the sediment from here, which tends to be smaller and more rounded because it's close to the sea. Then up here it's more angular and bigger. Why? Because the rocks fall off the cliff, but also large waves throw up material to the back of the beach, like creating a storm beach, and you can see at the back here already, you can see lots of storm beaches, but material increases in size from the from the foreshore to the back shore. Mr. Tyrrell, should you show how you do that?
There we go. So we've got, just keep my social distance, Mr. White.
Yeah, very true. So we have the angular material, whereas that's more rounded, and we use what's called the power roundness scale, and that's all in the booklet as well. And you can look it up, and I'll show you some textbook theory on it as well. But basically, you look at that as well. That's a factor. And what else do we use that, Mr. Tyrrell? How we measure that? We use a ruler and.
So we've got we've got a caliper that you can use, so you can measure different axes of the pebble.
That's the long axis.
So the long axis. So for example, if we're measuring our long axis, the longest length of that pebble, we place it in the caliper. Make the two parts of the caliper meet with the top and bottom of the pebble. Demonstrating this badly. And then you record the number of centimetres, so that pebble is 9.3 centimetres.
Yeah. And you could do like the area, so you could use a ruler. I've got a ruler in my bag actually. We could calculate the actual area of the pebbles as well, rather than just a long axis. You've got more data.
Whether you use a ruler or again, you could use the calipers for the different
job done. Okay.
axes.
Nice one. So you've got angle, you've got sediment. We then do percolation rate, which is to do with having amount of water, and you basically get loads of water and you time how fast the water percolates through the rocks. You do that at the low water mark, then it stages all the way up to the back of the beach. So you do the angle every break of slope, we'll talk about that in a minute. You do the sediment every break of slope, every time it changes shape basically. And we do the percolation rate, which is collecting water and timing how fast the water moves. And generally percolation rate, it's really slower here than it is at the back of the beach, because the material, there's more air spaces and it's bigger, and that's an indicator to show that the influences the shape of the beach. So it's steeper, bigger material here and more shallow down here, and the angle will show that too, the sediment, and it's all connected. Another activity that we'll do as well is to do with looking at waves, and we have a formula which I'll talk to you either in the classroom or using the booklet, where you count a number of waves, divide by 11, and that decides whether the waves are constructive or destructive. Constructive waves build up the beach, destructive waves pull the beach apart, and that's another factor that can link into as to why the beach is the shape that it is. You've got all these factors: angle, sediment, percolation rate, waves. We look at the weather forecast. What's that, Mr. Tyrrell? Go for it.
So we've got our infiltrator tool here. Mr. White lovingly nicknamed it the Infiltrator-tron.
Yeah.
And we use that to test the percolation rate, how quickly the water travels through the infiltrator. And so, as Mr. White was saying, down at the edge of the beach, where you've got much finer sand or sediment, the speed at which the water will flow down there is much slower than if you're here, where we are now, at the top of the beach. So if I was to start filling our infiltrator up with beach sediment, how much water do we normally put through, Mr. White?
Well, you make a decision. Yeah, you can make a decision yourself of that, really. A litre.
So you need to bring a water bottle with you, and once you've filled it with pebbles at different stages at each break of slope, you pour the water through the infiltrator-tron and you time it as you watch the water drain away, and you record the time that takes, and hopefully what you'll notice is a difference in the sediment at the foreshore to the back shore.
Okay, so we've got waves, we look at the weather, that's always an indicator. If it's onshore wind, you've got a light onshore breeze now, that can indicate, which means the wind's blowing from the west onto the shore. That can create destructive waves or constructive waves. You have to look at why and how. Well, actually, it creates constructive waves. Really, there's a low wavelength as well, and a wave period, and they sort of bumble up the beach, and they gradually build up the beach. At this time of year, where there's not real high energy conditions, although there was some last week. Generally, it's quite low energy conditions at the minute, and so you get lots of grooming of the beaches and the sediment, so they build up the beaches. Whereas in the winter, you get much more dramatic conditions where you have high energy conditions taking place. Ideally, you do all these measurements at different times of the year. So if you did it in winter and compared it to the summer, that's a good sort of comparison. or you start now and you continue and collect your data right up through September, October time and November, then you've got some real good data. But you do the measurements all the time over that time, maybe 3 or 4 times probably, and you can compare them. You can compare them with another beach as well to see how the factors influence that. Okay, you can also look at longshore drift. You can time how fast that moves. That's another thing you could look at, how the sediments move across the beach over time. That's another one we could look at. They're the main ones. They're the physical factors really that influence beach morphology. So we go back to that now. Study of the physical processes. So angle of the slope, sediment, percolation rate, waves, weather. Those factors influence the morphology. Morphology is a posh word for shape of the beach at Millook Haven, or you could do it at 2 places. As you're looking at the physical process, not the human influence, it's the physical process. Okay, right, we'll leave it there for them. So that's the first part of the video. Okay, that's part 1. Part 2, we'll actually demo it. Okay, have this while you're watching the clips, please, so you can see the different ways of collecting the data. And as you say here, it all links back to this. And we need now also to look at hypotheses as well. But this is like an introduction to it, and it will stimulate you to ask us lots of questions. So when we have our first video conferencing, you'll have a list of questions that you'll say, okay, so you've done that, Mr. White, how does this work? How does this work, Mr. Tyrrell? You know, and so on. So that's the aim of this really. So that's part 1. Okay, thanks for listening.